The moon is really the first best thing to look at, and the number one reason why it's such a good thing to look at is because it is so easy to find. Most of the things that I'm going to share with you are a little bit difficult to find, but I'll talk about how to find them as well. So we're zipping over to the moon. The moon, you know, is our nearest neighbor, about 400,000 kilometers, 250,000 miles away. And here's a full moon view with just a few highlights. Each of those little black spots there, you can probably guess what those are. The numbers 11 through 17 with 13 missing. Those are the landing sites for the Apollo missions. They're all on the near side of the moon. What we're looking at right now is the side of the moon that is always facing us. The far side of the moon looks quite different. You don't have those lowland mare, the dark spots, the seas. Mare is Latin for sea or water, because the ancients saw those dark spots on the moon. They didn't understand the moon. They were trying to figure out what the whole distance was about. So they thought, oh, those must be seas. One of them is named the Sea of Tranquility. So you've probably heard of that. That's the site of the Apollo 11 landing and the Apollo 17 landing as well. I also highlighted a couple craters that are about 50 miles or 80 kilometers across. Tycho, the one at the bottom, that's a fairly new one, about 100 million years old. Copernicus, kind of middle top, that's also about 50 miles across. That's about 800 million years old. And one of the ways that you could tell the difference in age is you can see rays emanating from crater Tycho. When a big meteorite hit there, it spewed the ejecta out, and over time that gets worn down, so it's not as prominent in Copernicus. And those are things you can definitely see with your binoculars. You can see the mare with your naked eye. All right, we are heading to our next binocular object. This one, I said this is sort of spring and summertime binocular objects. This one is not so much a spring and summer object. This is more of a winter object. It's the Pleiades, so called M45 or Messier Object 45. I want you to see this pretty quickly because it is low on the western horizon. Within a couple weeks, it's going to be lost in the glare of the sun. But this is the typical view you'd get from the binoculars, typical size of the view. You're not going to see the Pleiades this bright in binoculars. They just don't gather enough light. But it would be approximately this size in typical binoculars. Typical binocular field of view, I don't know, maybe it was the first binocular field of view I learned was about 7 degrees. So I've made all of our binocular views about 7 degrees. Pleiades is based on the Greek word to sail, and it's also named for the 7 daughters of Atlas, because you can clearly see only 7 stars here, right? No, with the naked eye, I think with the glance, you'd probably say 5 stars. Here with the binoculars, you'd count maybe a couple dozen stars. All in all, the Pleiades has about 200 or so stars. It's around 450 light years away, so pretty close neighbor to us. And it is young, so about 100 million years old, essentially the same time that the Tycho crater was being formed. And I just learned this when I was doing some research. The earliest known depiction of this was from a northern German Bronze Age artifact, and that was dated to approximately 1600 BC. So the first publication of the Pleiades was about almost 4,000 years ago. That's an open star cluster. You're going to see a lot of open star clusters in our tour, simply because those are easy to find with binoculars. Those won't be the only things we look at. We'll look at a couple other different types of things as well. But we're going to the constellation Cancer. What we're about to find, you can go from the 2 bright stars in Gemini, Pollux, which is the one closer to the arrow end, and Castor, which is a little bit farther away. Follow those 2 sort of straight down to the constellation Cancer, and that looks like an upside down Y, or the Greek letter lambda, right near the junction of those 2 lines of the constellation. That's where we're going to find our next object, which is called the Beehive Cluster. You can't really see it in this view, or I've got some glare on my screen, maybe you have glare on your screen too. In principle, it's visible to the naked eye from a fairly dark site. And by the way, you can see the left of the field of view is the moon. When I made the recording, that was the location of the moon. So the moon isn't going to be in that location tonight. Again, this is your typical binocular field of view. It fills up a pretty good chunk of that field of view. This has about 1,000 stars. And by the way, when I zoom in, most of my zoom ins will be about a degree in size. So probably what something would look like through a smaller telescope, a smaller wide angle telescope. This was called the Little Mist by the ancient Greek poet Eratos, about 200 BC. It's all been called a little cloud because at a glance it sort of looks cloud-like. Those points of light sort of blend together in your mind. This was something I didn't know until I just did some more research, or maybe I forgot it, but the ancient Greeks and Romans saw this object as a manger from which two donkeys, nearby stars, were drinking from. This is probably, I'd say the Pleiades is probably the best open star cluster to find because it's easy to see, it's interesting in binoculars. Probably the Beehive Cluster there would be second. That'll be above the horizon for the next, easily for the next month or so. Although it's closer to setting than rising, so you do want to catch it pretty soon. This next one is the Coma Star Cluster. We're not going to zoom into this one because the reason I chose this is it almost perfectly fits a binocular field of view, roughly 7 degrees across. This is actually the second closest star cluster to us. The Hyades, which is near the Pleiades, is the closest one. This one's about 300 light years away. It used to be part of Leo's tail, but then when Ptolemy formalized his catalog of constellations about 2,000 years ago, he made Coma Berenices, or the hair of Berenices, Queen Berenices, a separate one. So that cluster, maybe think of the Coma Star Cluster as a tangle in her hair. The next one we're going to is Messier Object 13, M13. And I find that using the bright star Vega in the constellation Lyra. So I kind of jump from Lyra to a sort of bright star in Hercules. And obviously these red lines aren't in the sky. But this is what's called star hopping. So these arrows sort of lead you through from a bright star to another sort of bright star to another sort of bright star. And then you see that hexagon, or that trapezoid shape. Oops, don't want to say hexagon with fifth grade teacher listening. That trapezoid shape, that four-sided figure, that's often called the keystone. That usually represents Hercules' body. We're going to zoom in to the binocular field of view. Again, M13 is not going to look this bright in your binoculars, but it will definitely look like a fuzzy patch. This is one of the first quote-unquote challenging objects that I share with people because it's tough enough to be a challenge, but it's easy enough to find. And it's also nice because in that binocular field of view, you saw that upper star in the corner of the keystone. So Messier 13, M13 is a globular cluster. And a globular cluster, those are sets of about 100,000 to maybe 1 million. This has about 500,000 stars. These are clusters, clumps of the oldest stars in our neighborhood. Globular clusters orbit the center of our Milky Way galaxy. The center right now, it looks just like a solid glob in the middle. Of course, it's not a solid glob, but the screen resolution doesn't do it justice. But if you were on a planet orbiting a sun in the middle of that globular cluster, you would see the sky just filled with stars. And a little bit later, I'll show you a simulation of what that looks like. This was discovered by Halley, for whom Halley's Comet is named, in the 1700s. And in 1974, humans sent a message from the Arecibo Observatory in Puerto Rico in the direction of M13. It contains some encoded information about DNA in people. So that was really our first formalized attempt to communicate with other stars or people around other stars. The stars themselves probably aren't going to listen. So keeping up with the globular cluster theme, this is Messier object number 4. This is probably either the first good or the second good globular cluster to find because it's so close to in the sky to the red supergiant Antares. Antares is really easy to see. So if you can find Antares in binoculars, just get that in your binoculars, nudge Antares off to the left a little bit, and the globular cluster Messier object 4 will show up. This is a fairly close globular cluster, about 7,000 light years away. M13 is about 23,000 light years away. This appears about the same size as the full moon in the sky or in your binoculars. Let's see here. Oh yeah, so we're going next to the simulation of what the sky would look like. And I've got the URL at the bottom. It's going to show pretty quickly. You probably won't have time to write that in. But this is obviously a simulation from a star in the middle of a globular cluster. In a globular cluster in the middle, the stars are hundreds of times more densely packed than in our neighborhood of stars. So the sky, astronomers think, would look about 20 times brighter than the full moon when you got the sky with the full moon. And a full moon sky, you could read a big print book by. So this would sort of be like probably a day during the day, but where there are really, really dark clouds. So it's light enough, you definitely drive with your headlights on, but you would call it seeable. And again, if someone wants that, the link to the article that came with that, that I just showed you, I can perhaps put that in the chat. I don't know if I've logged in, but I'll figure out. You can email Deanna or myself too. The next one is probably one of the most fun objects to see. I'm not going to tell you the name of it now. It's in the middle. See if you can guess the name. Again, this is in your binocular field of view. Afterwards, I'll show you how to find it. It's in or near the constellation Sagitta. I think it's on the border of Sagitta and Vulpecula, the fox. So Sagitta is the arrow, Vulpecula is the fox. I think it might actually be in Vulpecula. All right, any ideas what it could be called? Well, you probably didn't think that it was called Brocchi's cluster or Al-Sufi's cluster. The informal name of it is the coat hanger cluster because it looks like an upside down coat hanger. It is not a true star cluster though, it's just a chance alignment. Those stars, those 10 bright stars, range in distance from about 218 light years away to over 1,000 light years away. And in fact, the 3 closest stars in that grouping of stars are farther apart than stars in our neighborhood. So they're not a true cluster of stars that were formed from the same cloud and that are moving together. Yeah, oh, and it was mentioned, you see Al-Sufi. Al-Sufi's name will come up again. He was a Persian astronomer who wrote a book about stars, the Fixed Book of Stars, in about 9 something or other. But so to find that, you can see Vega. We used Vega before, and if you look in the upper right-hand part of your screen, you can see the Hercules cluster. But move your binoculars from Vega down to Altair, which is another bright star, another one of the 15 brightest stars in the sky, and you'll pass by the coat hanger cluster. If you look super closely at your screen, you'll see it's right at the tip of the arrow that I drew there. Let's see. Oh, in 964, Al-Sufi, the Persian astronomer, wrote the Fixed Book of Stars in 964. So next we are going to the Andromeda Galaxy. Again, we'll use some star hopping from the Great Square of Pegasus. That bright star, go from that star to a slightly dimmer star, and then up to a slightly dimmer star, and then you can see those 2 little arrow jumps across the word Andromeda to the Andromeda Galaxy. The Andromeda Galaxy is probably, if you've heard of any other galaxy, you know that we are in the Milky Way galaxy. The other galaxy that you've probably heard of is the Andromeda Galaxy. So we'll go to a binocular field of view here. And you might be surprised to think that this galaxy, which is 2.5 million light years away, and I've tossed around the word light year a lot. A light year is a measure of distance. It's the distance that light travels in 1 year. So a ray of light that left the Andromeda Galaxy 2.5 million years ago is just reaching the Earth now. This is really big in your field of view. It fills that much of your field of view. From a super dark site, it's about as wide as 3 full moons in the sky. So we're zooming in to a view that you could get in a small telescope, except you probably wouldn't. So that's a little bit of a paradox there, because this is about the size that would fill your small telescope. But your small telescope wouldn't gather enough light except to get probably that center galactic bulge. This is kind of like looking at the Milky Way galaxy. The Milky Way galaxy has that center galactic bulge of stars. There's a supermassive black hole in the middle of our galaxy and in the middle of Andromeda. The Andromeda Galaxy has neighboring galaxies. If you've ever been to the southern hemisphere, Earth, and looked in the sky, you may have seen the large and small Magellanic Clouds. Right below where I say that this was first described by El-Sufi, that's one of the neighboring galaxies. And then just above the M in Andromeda right now is another one of the neighboring galaxies. And then there's some smaller ones that can't be resolved. You can see some light bands of nebulosity. You can see some dark bands. Our Milky Way has light and dark bands. The sharp points of light that you see are not stars in the Andromeda Galaxy. Those are stars in our Milky Way galaxy that just happen to be in the foreground. Those are like the people in the stadium that are sitting between you and the field of play. Remember when you saw Andromeda zooming in the simulation? That is going to happen for real over the next 2 billion years. In about 2 billion years, the Andromeda Galaxy isn't going to be doing what you just saw there. It's going to be moving towards us, and the Milky Way and the Andromeda Galaxy will collide with each other. The next thing we're going to is called the double cluster in Perseus. It's on the border between Perseus and Cassiopeia. Cassiopeia makes a W in the sky. So follow stars 2 and 3 in the W, about twice the length of that little W segment down and to the left, you'll get to the double cluster. This is an object that is also almost ideal for binoculars. Again, people think they need a telescope. Sometimes a pair of binoculars is the best tool for an object. So it's not just, well, I wish I could see the double cluster with a telescope, but I can't afford it. No, binoculars are a better tool for you to enjoy the double cluster, in my opinion. It's visible to the naked eye from a super dim site. It's about 7,000 light years away, and it is very young. So I mentioned the Pleiades is on the order of 100 million years. The stars in the double cluster are about 12 million years old. Double cluster consists of 2 clusters. That was super insightful. I hope you wrote that down. And I wanted to share this. I didn't have these numbers memorized, but this is often a way to quantify cluster sizes by solar masses. So that doesn't mean that there are 3,700 stars in one and 2,800 stars in another. It means it has the mass of 3,700 of our suns or 2,800 of our suns. Typically, it means that there are more stars than that because the typical star is less massive than our sun. But it could mean that there are fewer stars than that if it consists of a lot of giant stars. And I do believe those 2 galaxies do consist of a lot of blue giant stars. That's also one of the best binocular objects for you to memorize its location because it is circumpolar for most of the United States, meaning it doesn't go below the horizon. The globular cluster in Hercules is above the horizon most of the time, but not all of the time. The Pleiades is above the horizon, I don't know, roughly half the time. So that one isn't as good to memorize. So now we're going to visit a few more objects in our solar system. These don't rise until about 3 in the morning, and you can find them in the southern sky, the southwestern sky, sorry. No, I'll get this right. The southeastern sky at about 5 in the morning. So a typical binocular field of view now will fit both Saturn and Jupiter. You likely will not see Jupiter's 4 biggest moons with binoculars, although it is possible to do so. If you have a tripod for your binoculars, or even better in terms of money, you can make your own what's called a monopod. So you can just take a big dowel if you have an old, like a big push broom, because those usually have pretty long handles, and then just go to the hardware store and find a double-sided screw, or just a screw without a head on either end that would screw into your binoculars if it has an opening, and then screw the other end into that big dowel, your broom handle. And just something like that, a monopod, creates a lot of stability and would allow you to see probably a couple of Jupiter's moons if they were far enough away. Probably all of you are familiar with Jupiter, at least a little bit. You probably know it's the biggest planet, and it is indeed. If you know only one other thing about Jupiter, you probably know about its great red spot. So that red spot has winds of about 400 miles an hour, or 600 kilometers per hour, and it is a giant storm. That storm has been raging for 200 to 300 years. The first people that looked at Jupiter and made note of its appearance, not by photography, because cameras weren't invented until the mid-1800s roughly, but just people sketched Jupiter. People sketched the storm. It's really interesting to look at people who sketched the sky before the age of cameras. They did a really good job. And some of those sketches are better than some of the first photographs. The different stripes that you see, those are different cloud bands. Those are winds moving in different directions, either west to east or east to west. The Earth has that same structure. If you remember from your middle school history, of course, the Europeans came over to the United States. They were blown by the east to west winds in those mid-latitudes. Above those mid-latitudes, the winds blow from west to east. They're the polar easterlies. Near the polar caps, the winds blow in the opposite direction. Closer to the equator, the winds blow in the opposite direction from the western hemisphere to the eastern hemisphere. They're not as noticeable on Earth because the Earth isn't constantly covered by clouds, but someone who observed the Earth very carefully from off of the Earth, they would notice that same structure if they mapped the general cloud motion for years and years. With the binoculars, you saw Saturn and Jupiter in the same binocular field of view, so we're going to zoom in on Saturn. Again, if you ask someone the one thing they know about Saturn, they're probably going to say it has rings. They'd probably call it the ringed planet, and to call it the ringed planet would be a little bit of a misnomer because all of the outer planets, Jupiter, Saturn, Uranus, and Neptune, all have rings. Saturn's are the only ones that can be visible, that are visible from the surface of the Earth, and those, of course, it was the first planet discovered to have rings. Those rings are made of ice. Not all planetary rings are made of ice. Jupiter's are more rocky in nature. And Saturn's moons, or Saturn's rings, are both created in part by ice from the ice moons, and also shepherded or sort of kept in line by smaller moons as well. Just like sheepdogs help herd the sheep, there are shepherd moons that help keep Saturn's rings in line. Saturn's rings are thin, sort of on the scale of a piece of paper. If you compare the size of your typical notebook paper to the thickness of it, that would be approximately the size of Saturn's rings in span compared to the thickness of those rings. From one end of the ring to the other that you see, there's tens of thousands of miles, tens of thousands of kilometers, but the rings range from maybe a kilometer thick to a few meters thick. So think tens of thousands of kilometers to 1 kilometer. That's probably a greater difference than the size of a paper to the thickness of the paper. Oh, another fun fact about Saturn that you've probably heard is if there was a bathtub big enough, Saturn would float. That's a little bit misleading because the outer layer is gas, and I'm not sure if gas can float in water, but something that dense, Saturn's density overall is less than that of water. So the final morning planet is Mars. Mars is near the constellation Capricornus. That brightest star, just look a little bit to the right of it. That's how you'd find it, although that's a little bit misleading because Mars would be brighter than that star. Mars is the planet that we've sent the most probes to. It's not our nearest neighbor. Venus is closer to Mars at its closest point. But Venus is very hostile to probes. So a few highlights. Olympus Mons. You can't see it super well there, but it's right at the end of the tip. That is the tallest volcano in the solar system. It's about 22 kilometers or about 14 miles. You can sort of see the outline of it there. The outline of Olympus Mons would be about the size of Washington and Oregon put together. Between Olympus Mons and Valles Marineris, which is a valley that would be as long as the United States is, you can see 3 other volcanoes. That region there with Olympus Mons and the others is called the Tharsis region. Some people consider that region one gigantic volcano. Valles Marineris, like I said, it's about the same length as the United States. Differing views as to how it was formed. Most astronomers think it formed similar to the East Rift Valley in Africa, just sort of split up. The ground split there due to tectonic activity, I'll use that word. But it's also, there's been erosion from water and wind. You can also see the polar ice cap sort of receding away from us. The north and south pole of Mars have polar ice caps. There's a little bit of afrozen H2O in there, but for the most part, it is dry ice, so solidified carbon dioxide. We are now returning to Ellensburg, back to the building from whence we started. That's the end of the formal tour.